All right, we're looking at page 67, number 17. A telecommunication company wants to build a relay tower that is the same distance from two adjacent towns. On a local map, the towns have the coordinates 2, 6, and 10, 0. So we need to explain how you could use the right bisector to find possible locations for the tower. So the reason why we want the right bisector is that wherever I make this telecommunication tower, it will be equal distance between both towns, anywhere along this line. The distance between each of these towns would be equal. All right? Noting that, we need to find the equation of this particular line that we can build the telecommunication tower on. And to find the equation, we need some important information. First of all, how would you draw a right bisector? Hopefully you're thinking, okay, to bisect, we need a midpoint. There it is. And a right angle means they're perpendicular. So we need to find the slope of this line. Once we find the slope of this line, we then can find the right angle slope by taking the negative reciprocal. That'll give you the slope of this line here, the orange line, and using the midpoint, that point right there, and that line, we can find, and the slope of that line, we can find the equation. So let's go through this. So, midpoint of AB is going to be add the x's, divide by 2, add the y's, divide by 2, and we get a value of 6, 3. How does that help us? Well, 6, 3 is our midpoint. We now need to find the slope of AB. Slope of AB. We take the coordinates 2, 6 and 10, 0, subtract them. Okay, don't forget you write them going upwards and subtract. And we get 6 over negative 8, which is negative 3 over 4 reduced. Once we know that is reduced, we can now take the perpendicular slope, which will be 4 over 3 positive. Remember, it's negative reciprocal, so change the sign, and flip the fraction. So this is our perpendicular slope. We're going to use the perpendicular slope and sub it in, as well as the point that we found, which is the midpoint. Plug it into the equation y equals mx plus b to find our b, and we find out our b value is going to be, so we plug it all in, y equals mx plus b, and we get b is equal to negative 5. So therefore the equation of the right bisector is y equals 4/3 x minus 5. Now let's say you were to expand this to standard form. How would you do that? Well, think about it, folks. Standard form says you cannot have any number with a fraction. There's a fraction here. So multiply the whole thing by 3 first. So you get 3y is equal to 4x minus 15. Once we do that, we move to the side where the x is positive. That would mean we would move everything to the right side. We get 4x minus 3y minus 15. And that will be our equation in standard form. No fractions, and the value of x is positive. All right, moving on to the next homework example. So you're given 3 coordinates, such as A, B, and C, and you're asked to find the equation of the median from C. So how do you find the equation of a median? We just worked on finding the equation of a perpendicular bisector. Now we're going to find the equation of a median. How do you find the equation of a median? Let's think about what a median is. First you need a midpoint, and then you connect that midpoint to C. You find the equation by doing the following. Use the midpoint and find the slope from the midpoint to C, and use that slope and that midpoint, or that slope and that vertex, to find the equation of the median line. All right, next one, page 67, number 13 now. Number 13 says a line segment with one end, which is at 6, 5, and that's known as C, has a midpoint at 4, 2. All right, and you're asked to determine the coordinates of the other endpoint, D. We don't know where it is, but we know it's somewhere. So, D has the coordinates x, y. And now what we need to do is use the formula to find the missing values. So think about it. If I know x plus 6 divided by 2 has to equal, that's right, 4. So x plus 6 divided by 2 has to equal the x value, the midpoint. Do the same for the y. Y plus 5 divided by 2 is equal to 2. So what are the values of x and y? Well, x is equal to x plus 6 is equal to 8. X is equal to 2. The other one, okay. Now don't forget, where am I getting these coordinates from? Remember, this is the midpoint formula. Midpoint formula is add the x's, divide by 2, add the y's, divide by 2. So what I did is I took the x's, and I know that that value has to equal 4. I know that my y values has to equal 2. So I set it up, multiply both sides by 2 to get rid of the fraction, and then solve for x. So in this case, 2 plus 6 divided by 2 is going to give me 4. And do the same for this one. You get y plus 5 is equal to 4. And then y is equal to negative 1. So the coordinates of this are going to be, of D, are 2, negative 1. That is the coordinates. Now, a method you could use to check it is to be able to take this and plug it into this and see that you do get this value here. All right, another way we could do is find this, you know that the slope on this line is the same anywhere on this line. So the slope between the midpoint and C has to be the same as the slope between D and M. Just another way to look at it. All right, page 89. Let's look at page 89 and see what the question asks on page 89. Page 89, number 10, talks about determining the shortest distance from the point 5, 2 to the line represented by y equals 2x plus 1. Use a diagram to check your answer. So here's our diagram. All right, and you're to find the shortest distance. Now, the shortest distance to this line is going to be at a right angle. It is not at a perpendicular bisector, folks. What it is at a right angle to the line will always be the shortest distance. If you were to have actually connected it, let's say you had coordinates here and here, for example. Let's just look at another one. For example, you could have had coordinates at the following, there, and we had connected this to make a triangle, folks. So I connected it to make a triangle like this. What actual line is that on that triangle? If you're thinking about it, you guessed it, that would end up being the altitude. So the altitude is actually the shortest distance from a vertex to the opposite side. All right, knowing that, that's going to help us actually understand what we're trying to do. So question 10 says determine the shortest distance. So we need to find the value of this distance. So we need to have this coordinate, which we already have, but we need to find this coordinate. That's going to be key. Once we know what this coordinate is, we can then use that to find the length of that yellow line that you see here, the length of this yellow line. All right, so how are we going to do that? Well, to find that, we know that this has an equation. So all we have to do is find the equation of this line. To find that, we know that the slope of this line is actually the negative reciprocal of the slope of this line. The slope of this line is actually 2, as you see here. So the perpendicular slope is going to be negative 1 over 2. Why is that? Remember, it's perpendicular, so the negative reciprocal of this line is negative 1 over 2. We need to find the equation. So we use 5, 2, and we plug it into the equation y equals mx plus b. By doing that, we get 2 is equal to m times x which is 5 plus b. We find out that b is equal to 9 over 2. So the equation is negative 1/2 x plus 9 over 2. We have our two equations. Remember, we needed to find the equation of this line and the equation of this line and find the point of intersection. So, by doing that, we're going to do the following. Okay? Now, what is this point? It's 7 over 5, 19 over 5. Let's find out why. Let's actually do the math and come back to this page in just a minute. So we're going to come back to this page in a second. Move over. There we go. We want to do we have the two equations, which we got earlier. Here's our two equations. What do we do with this? We're going to use either substitution or elimination to get the x and y values, the coordinates of the intersection point. So we set 1 minus 2, and we do the following. And we took equation number 1 and subtracted number 2, and this is what we got, folks. Okay, moved it to the other side, and we got x is equal to 7 over 5. So we got our x value. Plug it into either 1 or 2. Hint, use 1. And you find out that the coordinates for the y value are 19 over 5. What is this? These are the two intersection points. So we're going to go back to the other graph for a sec. There we go. Now, what that's given us now when we got that, we have that intersection point here. We have this coordinate here. We can now find the length. That's right, folks, because the question asks, find the length of that shortest distance. So we find the length using the formula for distance, and we find out that it's so it's 9 over root 5, or root 81 over 5. I want you to notice something unique, though. This has important properties that you're going to find out later what those are. But at this point in time, all we need to know is the length of that line, and we've done so. All right, now that we're done this, let's stop the video now, and we'll go on to the last question that I want to take up. See you on the other side, folks.